Hello and welcome to GM-BIST construction. This is Benedict, your instructor. Today we are going to learn how to import or export our DS file to our PROTASTRUCTURE. We'll be doing our modeling, our analysis, and our detailing. And so let me take you to our 3D. So we have our 3D here. So this is a building we are going to actually model, design, analyze, and detail. So it's always very important that before you carry out any structural design, you should go through your 3D. Now your 3D will actually give you an insight or a view, a clear view of what is involved in the exterior design. You can see in our 3D here we have a cantilever here at this place. Now when you go to your 2D, those cantilever at some point may not be clearly stated out. You may not actually get the full concept of what the architect wants. So it's always very important that whenever drawings are being given to you, you always, as a structural engineer, you always request for the 3D. I know that some architects will actually find it difficult sending it to you, but you have to talk to them so that you have a clear understanding of what you're about to design. The truth is that architects are actually producing or designing complex building. Cantilevers actually add beauty. When it comes to aesthetic, the cantilevers add a lot of beauty to every building. So getting that and trying to design all of this will actually help you, because you are designing for strength, for economy, and so at least these two factors you don't play with them when it comes to design. So we'll now begin. So the first thing we will do for every structural design you are going to do, you must first of all study your drawings very well. Your floor plans, you study them very well. You study your 3D, your 2D designs very well before you begin any modeling or analysis. So today we are not actually going to insert our grid lines here or our columns. We'll just be exporting them this way, in this format, in the XF format, to our PROTASTRUCTURE. So I will first of all try to export my ground floor and my first floor. Once I highlight, I click W, enter, then I save it. Let me save it my desktop. Say class 1A. So the format is DXF. I will save it. Okay. So I will load my PROTASTRUCTURE. So I have new. So let's say class tutorial. Then the next thing, I will go to my BS 8110, click OK. Then I will go to my building setup. Okay, before that, let's go to our settings. Let us do some settings. Under beam, steel bar and links, I will change this. Under general, let us see. Okay, I will go to my slab design. My minimum steel bar size, my slab will be 12. Appearance, show number of bars. So I'm done with this. So I can still come to analysis, building analysis, pre-analysis, project parameter, my foundation. I will choose my soil bearing capacity. So grade, I will choose my lower limit. This, all of them, they are brace columns that within a wall. The title, we title of my design is Toes Suspended Floor made by GM-BIST Construction. Checked by the engineer. Project is GM-20 date, and this is 28 10/2024. So these are not actually important, but you can actually feed them up. So we edit our material. The grade of concrete, we'll be using 16 or 20. Our concrete columns, select or check all 16 20. Concrete walls, select or we use Y12. For concrete beams, select or use Y16 and 20. The slab, select or we use Y12. Links, Y10. Go to foundation floor. This we select and we unselect all. Use Y16, Y20, and the links still remain Y10. So we are done with our loading combination. Okay, so we still go to bidding, set out, add. So we actually save it in our desktop as +1. Then we click. So once I check it, you see it appearing here. So what we are actually going to do, we are not going to import anything here. We're not importing our grid lines, we're not importing our columns. We stop at this point. So okay. So go to modeling. So under modeling, we go to grid lines. This is A. Change it to P, capital P. Here. C. D. E. F. This is for the ground floor. So we change direction to S now. This is 1. This is 2. This is 3. This is 4. This is 5. This is 6. So we now still go to modeling. We now edit our columns. So the size of our wall is 225. 225. 225. So we want to centralize it with the grid line. Let's insert one there. This is 225. 225. This is what we have. We now insert the columns. If there's need to actually change the size of the column, we'll also do that. For now, let's just insert the columns, not minding the space or the distance. So the architect actually did not position this on the wall, so we are going to offset this. Click on it, offset here, then you offset this one. So if you want to offset, it's Ctrl F2, then half of 225 is minus 112.5. So we delete this one. This one was just a guide. So we can actually take away this one too, and this will be 4 prime. So we'll now insert our column here. Let's put another one here. So we are done with columns now. So we'll go to our beam, our concrete beam. The size of our wall is 225. The depth is 450. So we'll take it this way. So here, let's take it this way. This way. Let's join this one here. Yes, and we have a lift here. Let's go back to our AutoCAD. You can see we have a lift here. So the lift, the first ground floor, first floor, third floor, all of them have lift. So this is what we do. We have to create our grid line for our lift. So for this can serve as our grid line for our lift, and then we need another one here. So let me offset this, keep it here. So this will become 2 prime. And this is where the lift is stopping. So I can now offset this one too. Offset this. This will be E prime. So I will now go to modeling, go to my wall. So this is 225. And here will be 112.5. So I will take it from here to here. I also need another grid line here. There's another grid line here. This is E prime prime. Now I'll go to modeling, go to wall, 225, 112.5. I'll take it this way, this way, this way, this way, this way. So this is what I have. I will now extend this beam to meet it here, and this one to join up this way. Okay, so you know that for every lift there's always an opening, or let me say a door. So we'll have to create our own door here for the lift. I'll just click on it, go to wall opening editor, click on it, then click on add. Then the height of the wall is 2100. Turn this one to 0. So you now have your opening. You now close. Okay, let's check the length of our beam. Once you click, you can see the length there. Beam length 6096. You can actually see that this is long, so we can change the size of this column to 450. Okay, let's look at it. Let's check this one. 6.1. and so there's a wall here, so we'll now edit this one. 450. You can either rotate, you can just click on it, so rotate column. me show you how to edit it so that it will sit on the wall. So this will be minus 112. You see positioning exactly at the edge of the beam. So also have a long length here. This is, so you can actually change this one to 450. You can either move it manually or using your arrow key, or you can just click on property, change this one to 112. So let's check at this place now if there is a wall. Okay, it's a partition wall here, so we can actually introduce our column here so that we reduce this span. So here we change the depth of our beam to be 600. Also change this column. For 50. Let me teach you how to rotate again. Property 112.112. So let's change this to 600. So we are done. Okay, so this is what we have for the ground floor. So the next thing I will do is to load my beam. Now I will go to edit wall load. So wall unit weight of Nigeria block is 3.47. Then the wall height. So let me teach you how to calculate the wall height. So this is our calculator. Now we have a beam depth of 600. We have a beam depth of 450. So I will actually decide to go for the highest overall depth of the beam, which is 600. I will assume 600 for all of them. But this is how to do it. Now the architects have actually informed me that the height of his building from ground floor to the slab, or let me say to the soffit, or for all the floor, is 3,600. So 3,600 minus beam depth, let's say 450. We'll do it in two ways. This is 3.15. If you want to put a 0, and the wall thickness, there's the thickness of the wall given to you by the architect, is 0.225. So for the walls that are 450, you can actually highlight this way, Ctrl V, or you right click and say paste. I want to teach you in such a way that you will understand. Now you have actually pasted on all the walls that has a beam depth of 450. Let's paste on this one, 450. Now this one is 600. So you can actually decide to edit this differently, or you can actually use that one and paste on all of them. So this is 3.47. The wall height is 3,600 minus 600, just 3 meters. Then this one will be 0.225. If you want to be doing it individually based on their depth, you can do this. So for our lift, there will be no need to add the weight. By default, the weight is added on our walls here. So the next thing we do is to insert our slab. Click on slab. The slab depth is 150. slab load, click on enter value. You have your room for general domestic use. Then for roof load, say 1.4 or let me say 1.2. Then I insert. I'll do this, I'll do this. Okay. Now, or let me if you don't want, you can actually remove the slab at this level. I will tell you why. I'll just remove this. So you are done with modeling of the ground floor. So the next thing is to go to building, set out, click on reference and drawing. Then you click on move, pick as a common point here, come and insert it here. Now the ground floor will not give way for the first floor. So see your ground floor here, and that's giving way for your first floor. Now this is your first floor. See it's having some cantilever around here. So let us go to our 3D and check out. See your cantilever, see them here. So that is what is exactly on your first floor. So now we begin to extend. We now create our grid lines. Okay, you click on this grid line here. Now you offset it. Let's keep it here where we offset it to be at the center. Control F2, 112.5. So this one will be 1 prime. Go offset F, offset again, Control F2, 112.5. So delete this one. So now you have at this place, and there's a cantilever in front here. So let us offset again this to this, offset again, Control F2, 112.5. So delete this. So this will be 7. So we'll now extend our beam, extend it this way, 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 so this place, this way, and you join it here. Okay, so I'll now join this one to here. Yes, I'll split it at those joints. Split it, this to here, split. We'll now extend this one to here. So let me look at my 3D. Okay, in the ground floor here we have this. We have a column here extending to our first floor. So it's actually not stated here properly. This is our ground floor. This is our first floor. So like I was saying, sometimes most of the details on the 3D may not be captured on the ground floor. So like what we have here, we have a column here where there's nowhere indicated on the floors here. This is the ground floor. There's no indication that there's a column here. This is the first floor. There's no indication. So when you have such detail on your 3D and there are discrepancies between your 2D and your 3D, you can actually relate it to your architect or as a structural engineer. Sometimes even without relating it to the architect, you actually know where the position of the column should be. So in that case, it's somewhere around here. So we are going to create our column there. But before that, let us look at the partition. You can see that this partition is actually wide. So I will now pick the property and partition this too, so that we don't have wide panel. So there's a balcony here and there's a column at this place. You can see. So we'll now offset. Let's check whether it's a column or a wall. So this is the column. It's actually a column. So we'll now go back to PROTASTRUCTURE. Now offset this to here. Ctrl F2 minus 112.5. Delete this. This is H and this is F prime. F prime. So it's actually stopping at this point. So let's see. Pick this point. We'll extend this here so that we'll have a balanced wall or a balanced beam. So after that, we can actually load our beam now. Let's copy this wall load. Copy here. Paste. Yes. Paste. So now go to our slab 150 room 1.2, click. Click. So we are done with our slab. The next thing we do is to click our slab strip in the X direction. So this is from beam to beam. Click, beam to beam, click. You hold your control key while you specify the direction to which you will go with your slab strip. And so we have another partition of a slab here, a small portion. So you can actually choose from slab to beam. So this is from slab to beam, so that you don't have a bend here. We're showing there is a continuation of the bottom coming here this way and trying to turn a bend. A bend which will return as your top. So this one you can see I've actually not changed it back. I will just click on this, update, so that there is a return of the top. The button is gone and it's still going to return as top. Then we change it to Y direction. or your control key to ensure that it's straight. This one will start from here. I want to take it all the way. Bear in mind, it's not the same reinforcement, that quantity of reinforcement that will start from here all through. So while detailing, you make sure you take note of that. So this one will start from a beam and end at a slab. So this will start from beam to beam. Beam to beam. So you are done with this. So we will now go to our story. On the story, you say insert story. So we are designing for a 2 suspended floor. So you insert 3. Which one? The other one will serve as a ground floor. And the other one will serve as a roof. Okay. We'll go back to 1. Story. Edit story. So each of the stories 3,600, which is 3.6. 3,600. 3,600. So the description, if you want, you can say this is ground floor. It all depends on what you want to type. So this is first floor. This is your second floor. You can give it whatever name you want. So our foundation depth will be 1,400. I will add zone roof as a normal story. Okay. So we'll still go back to story. We have inserted the story, we have edited the story. The next one will generate story. Now we are generating everything from ground floor to our first floor. Okay. The ground floor, which is a combination of the ground floor and the first floor on top. So we remove this one. We'll not generate the stories. We'll not generate beam. We'll generate our shear wall and our braces. Just click OK. So this is what we have. So the next thing we'll still go back to our AutoCAD, and this is our second floor. So let's just highlight it. W, enter. Save it on the desktop. Class 1B. Gonna be class 1B. Okay. So go back to PROTASTRUCTURE. Go to building settings. Go to external. Add class 1B. Activate. Let's check whether it has sat on the same position. Is it? No. So we now move it. Let's move. We can have a common place. This is what is showing us our grid line 2. Okay. So we can actually move this one from here to here. Okay. So that all the grid lines will be the same. There's actually a small discrepancy in the grid line, but the difference here is not actually much. So now you can actually see that there are some columns sitting inside a given space. That is the room. So you delete this one away, delete this one away, delete this one. Columns don't have to be inside your room. And this one still okay, but this one you don't need it at this level again. And this one there's no problem. If you see that this thing is actually not balanced, you can still come back to building layout, building setup, and remove. Remove everything. Now you see add again. Activate it. Now you move it. Move this one to here. Okay, I see it now. So this one is inside the room. So you now insert your new columns. Now you don't have columns at this age. You don't have at this age. So now this is what we're doing. We'll go to our view, then we'll go to type vertical, view, 3D. So we'll type vertical, so that whatever you are doing here, you'll be seeing it in your 3D. Now I want to insert, for instance, if I want to insert this column now at this place now, let's check out and see where the column is. You can see, so our column is sitting on a beam. We don't have problem with that. Let's try to insert another one and see. See it still on the beam. We are good to go. Let's try this one. See, this is it, still on the beam. Let's try this one. See, still on the beam. So you can see that even without you generating your beam to the next floor, you can actually walk this way and model your building easily with your DX file. Once you just bring your DX file here, it will give you a guide on where to position your column. As you can see, this column now will just terminate here, what they say, an entrance door here. So you can bring this one to this place. Let's insert this and see. See the position. It's on a beam. We don't have issue with that. Okay, I think we have inserted our columns. Okay, let's bring this one to here. Let's see it here. See it highlighted, sitting on a beam. Let's save. Let's try another one. See, still on the beam. Let's try. Oh, we don't need a column here. Let's go to our 3D. Let's go to our 3D. You can see that at this age there's no column, so you don't need a column at that place. I will delete this away. So I will now insert my beam. I'll still go to modeling, go to beam. I'll still edit the depth of my beam. Thickness 225. The depth 450. I will start with 450. Then from there I can also, and then we have a back on it here at this level. So when we are done, we'll go and check in our 3D. Take this one all the way to this place. I'll connect this one here. I'll connect this to this place. Connect this. Connect this. Connect this. Let's connect this. Connect this. Connect this. Yes. So when you have a beam of this nature, a beam that is just tied without a support extending at the other end, it's likely that this type of beam will always fail. So it's better you have an extension here that will anchor at this place so that it will give it more stability. So at this place now we join this one again. Okay, so I think we are done. So let's check the depth, the length. 5.7. You can use a beam depth of 450 for that. Okay, Now, if you're not conversant with designs, you can actually design for all your beans to be 450. You run your analysis and you begin to edit. But out of experience, I've actually proven that when you have a bean of almost a length of 6 meters, definitely a bean depth of 450 will actually fail in such case. So if you see me changing my depth of bean, or changing the depth of my bean or the width of my bean, is because of the experience I've actually gotten from various designs. Okay, so we now load our bean at this level. So we have 3.47. So we have a bean depth of 450, and we have a wall height of 3600. So it's 3600 minus 450. So that is 3.157 because it's in meters. So this will have 0.225. Click or copy. I like this one. Hold your control key. I like this too. And paste. 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 So we go to slab. Still edit it. The depth of our slab. This is room. It's 150. 1.2. We'll edit this. We'll delete that and see fix another one. Okay, so we'll go to our modeling. We'll go to slash strip. We'll change it. And bean to bean. We change direction now. Let's check out 3D. So we have actually gotten this slab, this one. This can be a block wall. We have gotten this one, we have gotten this one. Then we'll be going to our roof now. So let us also check our AutoCAD. Okay, at this level we have a slab. Here. So let us measure the length of the slab. So let's say 1.09 or 1.1 at this level. So I can either offset this. Let me offset it. Offset 1. And this is 1 prime. So you see that I can use my polyline, take it from here, and here. I still pick my slab. Or I can extend my beam. Let me delete it. Extend it to this way. Now insert my slab. I click on my slab, which is my slab there. I see paste. So now this place now, I can change this to my cantilever to beam. You can see it that's now extended to that place. So I will change the direction to be beam to beam. Let's just check if there are other features I haven't included. Yeah, there's none. Okay, so this is our ground floor, this is our first floor, this is the second floor. So we're going to our roof now. You can see that we have actually done what we normally call in our AutoCAD general arrangement here, but we just imported our DXF file, and from there we are able to insert our columns and our beam. So whichever way is simpler for you, you can decide to use it. If you feel you can actually, you are more, it becomes flexible for you when you have your columns and your beam imported from your AutoCAD to PROTASTRUCTURE. You can as well proceed to that, but if you feel working with this way, this method, by exporting just your DX file to your PROTASTRUCTURE to model is still okay with you, you are free to do that. It's still a good one. So let's change the position of this column and see. Let's see where it is. Let me click on it so that this is it. Okay. Let me just delete it. So at this level now I can rotate it. Let me just rotate it. To be this way. So that is spanning to cover this length. Okay. So I'll go back to my AutoCAD. This is our roof. So I'll highlight our roof. Control W. Say class. Class 1C. Save. So I'll now generate this. Say generate it to this. I will remove this one. Remove this, remove this, remove this, remove this. Don't need this. Yes. So I will now bring in my roof. Say add class C. Okay. Highlight it. And see it's highlighted. I will now move it. So let us check where we have 4. We don't have 4. 3. This is 3. This is 3. So we now move 3 to 3. And say okay. Yes. So at this point now, we also have an extension here. So we just need to extend it to this side. But this is more like, let me say, a roof wall, like skating. You can actually use plaster to do it. But we have an extrusion here, which is in form of a slab. We have a slab here. We have a slab here. We have a slab in front here. So this is what we have all through. We have a parapet wall here. We have this. So we are going to implement that in our plotted structure. So we don't have issue with the columns. So I'll just go to my bin. So your roof bin is actually supposed to be 300, but it all depends on the span you are using and the load at which the roof bin is going to carry. So in this case, I'll be using 450 because of so many of the parapet were this level. It's 225. 450. And delete this. I can move. Now join this. So we have a parapet wall here. So I'll introduce my grid line. You can see that even at your roof level, we are still introducing grid line. So there's no crying in doing that. You can just offset it. Control F2 112.5. On 2.5. So take this one to this. This will join to this. This join to here. This to this. To this. Okay. Then we have it here. Let us see if we can insert a column at this place. Let me delete this. Let's insert a column here. Let's see it in our 3D. That we ensure it doesn't fall within a room. See it here, sitting on a bin. So we are good to go. Click join. Therefore here, partition this. Partition this, and let's check out the span. 5 meter or 5 meter. So this is actually wide. You can either introduce a grid line and span it this way, or even without a grid line. At a point you can do that. Let me see if I'll do this. So there you reduce your roof trusses will actually rest on there. So this one, they are actually not load bearing beam. They're just for helping to reduce the partition, so that you don't begin to have your roof trying to buckle or sink. So we have a slab at this point. We have a slab here. So I'll be using modeling. Go to polyline here. Make it, join, finish, modeling, polyline. Modeling, polyline. Modeling. So this is what we have at the back. now go to our slab. So we can actually use a slab depth of 120 for our roof. We enter our value as our flat roof. Is general. The next thing you will do is to edit your beam wall load. Edit. This is 3.47. Wall height for this one will be 1.5. Half of the, you see, take half of the initial wall height you were using. So now you paste it on the load bearing walls. Ctrl P V. So load bearing walls. Some of them they are just partition. So you now go to your slab strip. This one, the one-way slab. Starting this one, deflection, or you so this is what you have for your roof beam. So this is an easy way of you modeling your design without exporting your grid lines and your columns to PROTASTRUCTURE. You can actually do everything here. So in our next video, we'll be running the analysis. We'll run the analysis. We'll be exporting it back to AutoCAD, where we'll be doing the detailing of our slab, our beam, our columns, and our footings. So do well to subscribe to our YouTube channel for more of our tutorial video. This is just what we have for you. It's very easy, very simple to model. You can see even our lift here has all the openings. So you can subscribe, as we'll be bringing the best and ensuring that for those who are just beginning to use PROTASTRUCTURE, we simplify it in such a way that you will use it, you will go through our video, understand the basics that are needed for you to carry out your structural analysis. If there are questions, if there's anything you want us to know, or if there's anything you want us to improve on, you hit the comment section. You can tell one or two of your friends to like and subscribe to our YouTube channel, for we'll be keeping you posted on every of our updates, both structural, electrical, mechanical, and architectural design. So we have actually done our modeling of our two-story. So if you actually need a plan, if you have seen the design and you love it, the structural, the architectural, and everything is set, you can just contact us. We'll provide it with just a small token of money, just to appreciate our efforts. We are also into supervision, execution of projects. Your GM-BIST construction at GM-B, your comfort is what we're always keen to do. Your comfort is our top priority. So thank you. I remain Benedict from GM-BIST construction.